All right, everybody, welcome back to CS 125. I don't know where you are, but it's a beautiful day here in Champaign, and I'm excited to be back with you. So today what we're going to do is we're going to finish up our conversation about the web. We'll talk a little bit about web APIs. That's kind of where we left off last time. Last time we kind of looked at some of the components of the web stack in terms of the protocols, the data that's moved around, whether that's HTML, CSS, or JavaScript is a little programming language. And then we had gotten to the point where now what I want to talk about is actually how does this system that you guys are familiar with from the perspective of looking at a website get reused in this kind of cool way to facilitate communication between different devices over the internet. Once we wrap that up, we're going to move on to a new topic today, which is about exceptions. So over the next week or so, in the time we have left together, we have a couple of additional topics that we haven't got to yet this semester that we still need to cover. And these are things that are actually pretty important. Exception and exception handling and exceptional control flow are things that, you know, as a Java programmer, you really should understand. So these are good things to tune in for. And we'll get started with that conversation today. All right, so to start, let's finish up talking about the web. So we got through the internet, we talked about the internet as infrastructure, we talked about the internet as a protocol that enables connectivity between devices. We talked about the web a little bit as a particular type of protocol that's layered on top of the internet protocol that has its own, its own rules and things like this about how a web client, like your browser, interacts with a web server, which is actually what's providing the content. So last time we talked about the content being moved across the web comprising things like web documents, HTML, CSS, and JavaScript, right? And that's typically what happens when your browser makes a request to a website, right? You get back HTML, JavaScript, and CSS, which your browser uses to lay out the page so you see something nice. But we can also use the web to implement something called an API. Now, the first thing we should talk about a little bit, although I think at some point you guys are familiar with this a little bit because of your work on the MP this semester, right? But what's an API? An API, remember we talked about interfaces in the past, an interface being a place where two things come together. An API is an application programmer interface, or an application programming interface. And the idea is that an API exists because somebody has built something and they want you to be able to use it. This is how companies expose like a service. We used to do an MP in this class where students would utilize an API provided by Microsoft that allows you to upload a photo and get information back about that picture that is calculated using machine learning. So they could do things like identify faces, and they can actually even write a little sentence that could be a caption for the photo. It's pretty wild. But that's one example, right? APIs exist because somebody out there in the world has built something useful or cool, and one of the ways they want to expose it to people is to provide an interface so that you can build things on top of it, right? You may want to build some sort of app. You may not want to, figure out how to do all the complicated machine learning required in order to do face detection or things like that on a photograph. So instead, what you do is you say, okay, well, we're going to pay Microsoft a tiny little amount of money, maybe more if your app gets really popular, but we'll pay them a little bit, and we're going to use their API so that we can utilize these image processing and image classification capabilities that they are providing to us, right? And on some level, you can think about an API as being kind of like a library. An API provides you with a bunch of different methods that you can call that do useful things. So with our photo processing API, one of those methods is something like, identify photo, and maybe it takes a picture, the data for an actual image, and what it returns back could be a string that says people playing in a park together, right? Or whatever, right? Disc golf final hole or something like that. That's very much like what you would do locally. Would use a library, right? You import it and you call the methods on it, right? So here's an example of an API. This is actually like sort of drawn from a real life API, but this is how it would kind of look in Java, right? So imagine that at some point I gave you this library and it exposed these functions, right? So I've got a function called get at location. It takes as a parameter. Now this is I haven't shown you every object you would need to understand in order to use this, every class you would need to understand, but this is like a weather location. And so you can imagine this somehow encapsulates the location information that this weather service, that this weather API needs to know, right, in order to provide the location, the weather for a particular location. And what you'll see is that this function is returning a reference to a weather info class, which is going to be something that stores information about the weather, right? And I might have a couple of different overloads of that getAtLocation function that takes slightly different parameters. And then I might have this way, imagine my weather app, when you use a weather app, typically you type in a string like Champaign, Illinois, and it needs to figure out like how to convert that to an actual location, coordinates probably in latitude and longitude, which you guys have been using all semester. So here's a little helper function that this API might provide that basically allows you to give it a little query, like a string that the user might have typed into a search bar, and return an array of different weather locations. Why an array? Because maybe more than one matched, and now it's up to you to figure out which one is correct. You might show another pop-up to the user that says, okay, here is potential locations, click one, and that allows them to finish the job of specifying which location they want weather for. All right, so on some level, a web API is designed to work very similarly to these APIs that you guys have been used to using as part of Java libraries. The only difference is that it's accessible over the web. And let's imagine how this could happen, right? So first of all, we already know that when I need to transmit data to a web server, like I want to purchase something or add something to my cart, there is a web request, an HTTP request that's designed to support that. It's called POST. There's another way of doing this, is URL parameters. We'll come back and talk about that a little bit later in this class. We also know that when the web server receives that request, it can do some processing. This is how dynamic websites work. So when you go to Amazon.com, Amazon doesn't have a page sitting there waiting for you. It looks at information that the browser provided about who you are and all sorts of things, and it uses that to make a calculation about what the page should look like. And it then assembles a page dynamically and sends it back to your browser, which is what you see. And here's the thing. When we talk about the web as you see it through your browser, what we've been talking about is web servers returning HTML documents, right? Documents using this HTML markup that can be interpreted by your browser. But there's no requirement that a web server actually return HTML. It can return anything it wants. And the response does not have to be in HTML. And so if there's a response, and so there's a format for the response that works better for transmitting data around, then maybe I'll use that instead of HTML, right? HTML is great for things that people are going to look at. HTML is a markup language. It's designed to describe how something looks. But a lot of times when you're using a web API, what I want is some data, right? I want structured information about the weather at a particular location. I don't want a website, right? I might use the data you provide in order to render a display that uses some nice pictures and graphics to show the user what the weather is like at a particular place. But what I want from the web API is data, okay? And one of the reasons why this whole system came about, and I don't want to dwell on this, is that, so I talked before about, well, you can invent your own protocols on top of the internet, and you can do that. But in a lot of places, there are rules about which type of protocols are allowed to get in and out of certain networks. You might have heard about something called a firewall. A firewall typically restricts access to different protocols to pass over a particular part of a network. And so what happened is that rather, this is interesting sort of the evolution of the internet. Rather than invent a lot of new protocols, what people have done is they've hijacked something like the web protocol, the HTTP protocol, to use to serve data, right? To use to be able to be part of a web API. All right, so let's look at how each part of this works in turn. So the first thing I have to be able to do is actually send arguments. When I call a function, so I'm drawing an analogy here with calling in a function, right? That you might use in a library. But instead, what this is going to happen is we're going to move in a library. When you call the function, the code runs on that device. Now what we're going to do is when you call the function, the code that runs is going to be on some other device across the internet. But I want it to look and feel pretty much the same way. So here's how we do that. So first of all, let's look at this call getAtLocation. In order to make this call, I need to provide an argument. So I actually need to pass some data to this function. That argument is a single object called location. That's the type weather location. And again, we could speculate about exactly what type of data that class encapsulates that's needed to be able to figure out, to return a weather info object that contains information about the weather. There's a couple of different ways of doing this. I don't want to dwell on these too long. One way is that I can actually stick it in the URL. And you guys have seen things like this before. You might not have known it, But when you've browsed the web, you've seen examples where there is a part of the URL, that part that's up in the top of your browser, the location that you're at on the web. Sometimes part of that is used to determine for a web API what information to return. So I could somehow convert the location to a string, and I could insert it into the URL, and I could do it that way. There's also this ability for GET requests to take parameters. And again, you might have seen this, and if you haven't already, look when you kind of go around the web next time. So for example, I'll just do this right now. Let's Google something. I don't know, let's Google weather, right? So if I look up here, right, and I look in my search bar, you'll see that I have search and then I have a question mark, and that's what starts a list of parameters. And then the way that parameters work in a URL is its name. So this is XSXSRF. I do not know what these are. I don't work at Google. An equal sign, and then there's some information, right? And then if I go down here, I can see there's an ampersand in my location. That means it's the start of the next parameter. So the first parameter was XSSRF. Again, I don't know what that is used by, how Google uses that information. The next one is source. Source is equal to HP. And then there's another one, EI is equal to 8M, I don't know, anyway. So this information, I'm not exactly sure how Google is using it, right? But it's present there in the location. All right. So, and I can do this. This is another way of doing things, query parameters. I can also use a post message, right? So in post, one of the things that's neat about post is that I can actually send a lot more information. In GET, the only way to transmit information to the server is to stick it into the location somehow that I'm requesting. In a post request, I'm actually sending the server a message. And so now what I put inside the body of that post message is up to me. And so I can stick something like JSON in there, right? So I could basically have the content of the post message look something like this. So here I'm making a post request to this particular location. That's kind of like the name of the function. And then the arguments could be serialized in JSON. You guys have worked a lot with JSON this semester, so you're used to seeing stuff like this, right? So now, essentially, this parameter up here, location, that I need to pass to the call is part of the JSON body of the post request. And then in here, I put however I serialize the location. And again, that's going to depend on the structure of this weather location object that I haven't been showing you. Okay, so that's how I get the data to the server, right? That's how I kind of make the function call. That's how I pass an argument, a couple different options for doing it. How do I get data back? Well, frequently today, and this is one of the reasons we've been having you guys work with JSON, there's a lot of web APIs out there in the world that return results using JSON, okay? So you would make that call, let's say make the post request or a GET request, and what the server would send back in response is not an HTML document. It's not something that's designed to be rendered by a web browser. It's JSON. It's a string of JSON that can be parsed by any client that supports JSON. And I think this came up in some of the MP write-ups, but if not, one of the reasons why JSON has become so popular is that every single language on Earth has a way to take JSON and convert it to an object. So whether you're using Python, Haskell, JavaScript, Go, TypeScript, Ruby, whatever, there's a way to take JSON and convert it into that language's equivalent of an object, which you can then use as part of your program. So here, for example, and this is an actual example of some JSON that was returned by an API that provides weather information. Here you'll see that there's this key called consolidated weather, and then inside that key, I don't know what this is, to be honest. I don't know how to parse this. The weather state name, this is kind of nice, is thunder. So you can imagine if you were like building a weather app and you were rendering this, you might put thunder in big type because that's kind of a description of the weather right now, right? The wind direction, when this request was created, what date it's applicable for, and then this goes on and on and on. And this object actually has lots and lots and lots of properties, which describe all sorts of interesting things that you might want to know about the weather. Okay. What's cool about this is that there are a lot of public APIs out there on the web. And so you can go and explore these and have a good time. And some of them are open so that you can use them as part of your own application. There are definitely free weather APIs that, and again, we may or may not have Ben come and talk a little bit about his bus app again this semester, but there's definitely a video up from last semester where he came in and told us a little bit about how he designed one of what I think is the better bus apps that's out there for our local transit authority here in Champaign. And one of the things that Ben pointed out, which made this challenging, is that the Champaign bus company limits the number of times you can use their API. So you can't make like 1 million requests to it per second. And so that actually created some challenges for him when he designed the system, right? But there are a lot of public APIs out there online, and you can have fun and go use them, right? So just to make sure that you guys, well, whatever. I mean, I won't go into this. Some of the tools that we use as part of our slides, for example, work in exactly this way. So those playground examples that you guys have been working with in the slide decks throughout the semester, those are all supported by an API that we provide as part of the class. And that API works by taking little pieces of Java code that you post to the server, running them, collecting the results, and sending them back to your browser, right? And so you guys have been using this little web API that we set up to support this application since the beginning of the semester. Okay, so I'll let you guys, as usual, post questions on the forum. And I'm going to sort of blunder on here into a complete terrible segue into talking about a new topic, which is exceptions. And so what we've been, one of the things that we haven't really got into this semester, although we've skirted the topic a few times, and every time that's happened, I've been like, wait, we'll talk about it later. Well, now we're going to talk about it, which is what happens when things go wrong. And there's a lot of different ways that things can go wrong in your program. So for example, somebody might call a function that you wrote, but they might not provide good inputs. Remember, we've seen this a few times. Like, what happens if somebody, provides, you need a positive value and they provide a negative value, what do? And we've been just kind of like waving our hands and trying to find a good return value to use that indicates that something went wrong, but that's not really the right thing to do. There are other times when things go wrong that kind of aren't your fault, right? So for example, you might be in the middle of transmitting some data from your device to some backend server, and then the network cuts out. What do? Well, again, I mean, that wasn't your fault. It's not a bug in your code. It's just something about the environment around you that's changing that you didn't anticipate. And this can cause problems. So exceptions and errors are a very natural part of programming, right? Both in terms of creating code that other people can use safely, but also just in terms of recognizing that the world around us changes, and there are times when things that we were relying on to be true, like the user has a network connection, suddenly stop being true, and those can cause errors to happen. So again, we've talked a little bit about cases where it's not clear what the right way to respond in a particular part of our program is. So here was an example. We had this like storage class that we were playing with. This was like a month ago, it's a long time. Feels like longer even now. But anyway, so we had the string storage class that we were using, and we were giving it a size. And this is one of the limitations of Java, which is that in Java, an int can be positive or negative. So here, the semantics of this constructor really require that the size be positive, okay? It doesn't make any sense to create a storage object that holds a negative number of strings. So this is kind of one of these examples where it's like, if you pass me a storage size is either 0 or less than 0, now 1 is also a little weird because it's like, if you just want to store one string, why not just use the string variable? Okay. I mean, this whole class is a little contrived because you want to store more than one string, just use an array of strings, but whatever. But anyway, the point is here that there are clearly bad, invalid values for storage size. And we would like to be able to do something when the user tries to create a string storage object with a bad value of storage size, right? Now, one of the things we talked about with our constructors that makes this challenging is I can't return null. There's no way to fail in a constructor. There is a way to fail in a constructor, you're about to learn, right? I can't fail by returning null. The constructor is always going to return a new instance of that class. But I can fail in a different way that we're about to talk about. Failures, so that's an example where the failure is due to programmer error. So here's a case where it's somebody's fault, right? Because somebody didn't read your lovely documentation. Your documentation says storage size, the size of the string storage, must be positive, but some thoughtless person didn't read the documentation. I know nobody would ever do that, and they called this with a negative value, and now you gotta do something. But the errors can also happen, because of, again, things that are outside of your control. So a user might not understand your directions. So here's a case where imagine that imagine that you have some input box as part of your app, and the user puts in some information, and it's supposed to be a number. You ask them for a number. And what you need to do is you need to take that string and now convert it into a number. And so there's this parse int method that's part of the integer class that you can use to do this. The problem is, what happens if they passed like foo, right? If they passed some bad value. And users will do this. They'll do this sometimes because they are confused. They didn't read your directions, right? You said, please enter an integer, and they entered foo. Sometimes they'll do it because they could think it's funny to mess with you. People that test apps will frequently do this to just see if they can break the app in a way that's ugly. Like, if you put in foo, what I would like to see is a nice pop-up that says, please enter a number. Foo is not a number. If your app crashes at that point, maybe it's not ready for the Play Store. All right, so what do you do in Java? So in Java, there are two pieces to this puzzle, okay? Because essentially, you can think about it this way. In Java, we need a way to indicate that something has gone wrong. This is sometimes known as throwing an exception. And there's an actual throw exception keyword. When you use code that could potentially cause an error, there's also a way to catch that, okay? And this is inside what's called a try-catch block. All right, so let's look at this. This is a new piece of Java syntax. This is kind of fun. We haven't seen this for a while. This is another block-based structure, so this probably should look very similar to the if statements and the for loops that we've already looked at previously. This is, again, another reserved word in Java, try. Try opens up a block. Try is then followed by one or more catch statements, right? So the way this works is that inside the try block, I put code that might fail, meaning that it might generate an exception. We'll talk about what those are in a sec. But something in this code might go wrong. Then what I do is, if that thing did go wrong, I have the opportunity to catch the error and handle it. Do something, okay? Now, the something that you do depends very much on the kind of errors that could potentially happen, right? I talked about one thing a minute ago. I might put up a pop-up that says this is an invalid input or something like that, right? But I might need to do other things. It really depends on the code you're writing. But the idea is I try to run some code. If that code throws an exception, I catch it. And then I can do some things to handle it and to clean up or to work around the problem, right? This is the language here is actually pretty awesome, right? There are some nice parts of Java syntax in terms of how it maps down to the real world, but this is one of my favorite bits, right? Where it's like try, it's very obvious. I'm going to try this stuff. If it throws an exception, like blows up, I'll catch it, and that's going to help me address any errors that might have gone on. Okay. So let's talk a little bit about how the catch blocks work. So catch blocks are designed to, the way a catch block works is that a catch block can allow you to catch a certain type of exception. So a certain type of problem. Java has a whole tree of different exceptions that are used to indicate different types of errors that occurred when I ran a particular piece of code. The catch block uses inheritance to figure out whether or not that exception is applicable within that block. So essentially what happens is that, and the catch blocks are tried in order, okay? So let's look at this next piece of code that has two catch blocks. And we're gonna get to these types of exceptions and stuff like that. But some of these you guys have already seen, because one of the things you've probably seen is sometimes when you run your code and you're working on one of the homework problems or in the playground or whatever, it throws an exception. It causes an error, and you see it. It said, stack overflow exception, or null pointer exception, or array index out of bounds exception. You guys have seen some of these already. That's the result of your code causing Java to throw an exception and then you not handling it. Okay. So here's an example of how catch blocks work. The point here is to talk about exactly which one gets run. Catch is sort of like else in the sense that only one catch block will be used, and Java tries them in order. So essentially, if the code that I tried to run in my try block threw an exception, something went wrong, the first thing that Java will do is it'll say, okay, is the exception a null pointer exception or something that inherits from null pointer exception? So some kind of thing that is a descendant of null pointer exception. If so, it enters this catch block. Okay. Otherwise, it says, okay, well, is the exception that was thrown something that inherits from array index out of bounds? So essentially, can I cast this to an array index out of bounds exception? If the answer is yes, then I run this catch block. If the answer is no, then I'm out of options. And at that point, what will happen is that exception will not be caught, right? So you think about an exception might have occurred. If you don't catch it, then what happens is it might need to be caught somewhere else. If nobody catches that exception, the program crashes. And that's why you've seen those exceptions before. So if you write code that causes a null pointer exception and you don't catch that null pointer exception, your program will crash and Java will print a nice error message that says this is what happened and etc. Okay. Try is like other pieces of Java block-based code where once I'm done with the try block, I go on and I continue executing the code below it. One important thing to understand about try though, and once we get to the playground, we'll experiment with this. When you're inside a try block, as soon as an exception happens, you jump into the catch block, if appropriate, right? So it's possible that only half the code inside the try block gets executed because I got to a particular point, it threw an exception, and then I jumped into the catch block. Once you leave the catch block, you do not go back into the try block. You go on. So you try, if an exception is thrown, you jump into the catch block, you run the catch block. Once you're done, you drop to the bottom and keep going, right? You don't go back into the try block and try to continue going. You just fall out of the try catch state. There's also ways to merge multiple exception types together if you want to catch more than one in the same block using this pipe operator. That'll also work. So try catch is one of these idioms in programming that gets used in a lot of places. So I just want to point that out because this is sort of, some of you may have seen this before, and some of you will see it again, no matter how you end up programming in the future. It gets used in Python. Now, so here's an example of a try catch block. In Python, they use except instead of catch, which, okay, I mean, catching is fun, right? I don't know, whatever, it's Python. JavaScript has a try catch block. This has a special bit that we'll talk about in a little bit called finally that the Java also has. All right, so let's play with this a little bit because, of course, this is always the best way to get a sense of how this works. Okay, so here's my code, and let's talk about what this does. So this is a function. I'm not sure I need this static keyword anymore. Let's try that. Okay, cool. So we can take off static. I'm still going through, and we've updated our playground a couple times this semester, and so I'm still fixing things that don't need to be there anymore. So I have this method called throw random error. Okay. One of the things I'll point out, and we'll talk about this a little bit later when we talk about different types of exceptions, is this new part of the declaration. And this is here to indicate that this method might throw an exception. And again, we'll talk about this a little bit later. So all I do here is that half the time, I use this random instance of the random class in Java to basically either enter this block or enter this block. So half the time I run this, it's going to generate a null pointer exception. Half the time, it's going to generate an array index out of bounds exception. And let's see how these are being generated, right? So here I create, and again, why does Java let you do this? I don't know, but it does. So I create an object reference called it. I set it to null, and then I try to call one of its methods. We know what's going to happen here. Boom, right? Null pointer exception. Down here, this is one that's probably more common. It's not such an innocent mistake, right? Or not such an idiotic mistake. I create an int array that's empty, and then I try to dereference the fifth element in it, and that's also going to blow up. Okay, so let's try to rewrite this using try catch so that we handle both of these exceptions. All right, so the first thing I need to do is I need to put my call to throw random error inside a try block. Okay. Now, one thing that's important to understand is that if you try, you gotta catch. There's no try without catch, right? I have to catch something, okay? And so I can do a couple of things here. One thing is that I can catch exceptions. And here's what I'll do. I'll print off that exception, and then I'll go on. So now what you're seeing, let me put, this looks a little bit similar, right? I'll put something appropriate. Okay. And now what you're seeing here is that, when I run this, I see that I've entered the catch block. One other thing here, let's put another print statement here so that we'll see that done will never get printed, okay? Because throw random error always throws an error. And so the catch block, so I try running this function and what happens is it throws an exception, I enter the catch block, and then I am done down here. I'll put another print statement here on the bottom, right? This does get run, okay? But that second part of the try block doesn't get executed because something caused an error, which then got caught. The catch block runs, and then I drop out and I continue on with the rest of my code. And so when you're writing your code, you need to keep this in mind. When you use a try block, it's possible that not all the code in there will be run, because as soon as anything in there throws an exception, you're going to jump into the catch block. Now we saw a minute ago that I can have multiple catch blocks, so let's talk about how that works. So let's catch null pointer exceptions. Okay, and so now what you'll see here is about half the time I enter this, and then about half the time I see this message, and this is because my program actually crashed. It crashed in the playground. And so you'll see I don't see bottom because this error was not caught by my catch block. It's not catching array index out of bounds exceptions, it's only catching null pointer exceptions. And so the program crashes and never reaches this final print state. If I want to catch both, I can do array index out of bounds exception, and then I'll print that here with a little bit of a different prefix so we can distinguish them. Okay. And now you'll see that, sometimes I see uh-oh, sometimes I see whoops, but in both cases I reach the bottom because I've caught the exception. Okay, let's look a little bit about how the catch block works. So the catch block takes, inside these parentheses, the first thing is the type of exception. The second thing is the name of a variable that will store a reference to the exception inside the catch block. So this looks a lot like declaring a variable, right? This basically says declare a variable called E of type null pointer exception. That's kind of what it's doing. The type of this variable indicates what type of exception this block will catch, but I also have access to this error variable inside my catch block. Down here, let's call it something else. I don't have to call it E. E is a very common choice of variable name for this type of error. It's sort of like I for a top level loop. It's very, very common. But if I want to call it error, I can do that. The only problem is now my code won't compile because this variable doesn't exist. But if I fix that, I'm good. So you can call that error reference anything you want. In Java, these thrown exceptions are objects. Remember, Java, everything's an object except those 8 primitive types. So errors in Java are also objects. They have methods. So for example, this I think has is a message. No, it doesn't like that. Let's just call toString. I can definitely call toString on it because everything in Java has a toString method. But errors actually have some additional methods that will allow you to extract other parts of it. It's just another object in Java, right? Just like everything else. Okay, so good. Now, one of the things that tends to flummox people about this whole system is how exceptions modify control flow in Java. So far, when we've been thinking about how your program runs, it's like, you go line by line by line, and maybe I have an if statement, so maybe part of the code doesn't get executed, or maybe I have a for loop, so some things get run more than once and stuff like that. But it's pretty much kind of like top down, might jump around a little bit. But exceptions introduce a new type of control flow. So they introduce a new way that control might, a new order in which parts of your program might get run, right? So here's what happens. Whenever an error occurs, when an error gets thrown, what Java does is it immediately jumps into the enclosing catch statement that can catch that type of error if it finds one. So essentially, it starts going up. So it looks inside the function that's running the code. If that code is inside a try block, it'll use that catch statement. Otherwise, it looks at the function that called that function and sees, did the function get called inside a try catch block? If it did, it looks to see if there's a catch statement there that can handle the error. If not, it keeps going. So it looks for the caller of the function, the caller's caller, the caller's caller, and it does this all the way until it gets to the main method that we remember is where all of our Java programs start. If the main method doesn't catch the error, then the program crashes, essentially. That's the last line of defense. So here, for example, if I look at this piece of code, let's think through what's going to happen here. So foo1 is going to throw an exception. That's what all this does. It throws a null pointer exception in this dumb way that we've learned how to do it, right? Create an object reference, set it to null, and then try to call one of its methods. Boom. Okay. So, but how did we get to foo1? Well, let's see. We called foo3, which called foo2, which called foo1. So now what happens is Java's like, uh-oh, when line 3 gets executed, Java will say, is this inside a try-catch statement in the function foo1? And the answer here is no. So now it looks at how did we get to foo1? And in this example, we got to foo1 by calling foo2. So now it looks in foo2. Is there a try-catch statement wrapping this call to foo1? The answer is no. So it says, okay, well, how did we get to foo2? Goes back to foo3. Foo3 is who called foo2. I think I said that right. It looks to see, is there a try-catch statement here in foo3? The answer is no. That says, how did we get to foo3? Well, it was foo4 that called foo3. So now it goes up to foo4 and it says, aha, I have found a try-catch statement. And this is actually where the next part of your program that will run. It doesn't matter what else is in foo2, what else is in foo3, or what else is in foo1. If foo1 crashes, the next line that gets executed, so essentially there was an error on line 3, the next line that gets executed will be whatever's in the catch statement in foo4. If foo4 didn't have a catch statement and this was called by main, we would look at main and then we would crash the program if we didn't find a catch statement. So again, so here let's put a print statement here and we'll say we'll just use this to identify ourselves. Okay. So you'll see I entered the catch statement in foo4. You'll also see that I did not finish running foo3 and I did not finish running foo2 and I did not finish running foo1. Okay? So here's what happened. Foo4 runs, calls foo3. Foo3 runs, calls foo2. Foo2 runs, calls foo1. Foo1 crashes, throws an exception. Now I look, is there a try-catch block here? No. Try-catch block here? No. Try-catch block here? No. Try-catch block here? Yes. Now, let's play with this example, and I would encourage you to do this. You know, I'll do a few permutations of it, but this is a great example to develop your intuition about how exceptions are handled and how they alter your program's control flow. Okay, so let's start by putting a try-catch block right here. Okay, so let's say that I knew something bad was going to happen. And I was ready, and I'm going to catch that exception here, and I'm not going to do anything. I'm just going to ignore it. Oh, check style. Oh, check style. Yeah, it doesn't matter. Okay. Okay, so this is interesting. I see foo1. Foo1 completed. The reason is I caught that exception. It got thrown. I caught it. And then I went on. So foo1 gets printed, foo2 gets printed, foo3 gets printed. Foo4 does not get printed because it's inside a catch block, and there was no exception. There was no exception thrown up to foo4. There was an exception thrown in foo1, but foo1 handled it. Right? That's another way to think about it. It's like delegation, right? Like foo1 handled the problem, and so foo2 is like, what problem, right? As far as foo2 is concerned, there was no problem because it never saw an exception. Now let's imagine what happens if I remove this, and now let's put it in foo2. So now let's say foo2 doesn't trust foo1, and so foo2 is going to put this in a catch block. And again, I'm going to catch this exception. Now, I don't see foo1, right? Because this line 3, crashed. It threw an exception, and Java said, uh-oh, what do I do? Okay, well, there's no try-catch inside foo1. Is there a try-catch inside foo2? Yes. Foo1 was called inside this try-catch. And so at this point, foo2 catches the exception, and then prints, and then foo3 prints, and everything else continues normally. Now, one thing I want to make sure you understand is that this doesn't prevent another function from calling foo1 directly. So let's say that foo4 just called foo1 right off the bat. Then the whole program crashes because foo1 throws an exception and foo4 does not handle it. All right? So in this example, foo2 is handling exceptions thrown by foo1, but that only gets used if we get to foo2, which in this case we do through foo3 and foo4. All right, so again, you can try moving these around. The other thing you can try doing is something like this. So let's change this to an array index out of bounds exception. And now what you'll see is now I'm back in this catch block. Why? The error that got thrown was a null pointer exception. So Java said, is there a catch block in foo1 that can handle this error? No. Is there a catch block in foo2? There is, but can it handle a null pointer exception? No. This catch block will only handle array index out of bounds exceptions. So it keeps looking, goes to foo3, no catch block there, goes to foo4. There's a catch block here that will handle any type of exception. That's the one that gets thrown. Okay, so again, this is one of those things that ask on the forum, fiddle around with it, but just recognize that you are encountering a new type of program control flow. You're encountering a new way that Java can proceed through your programs, right? And this type of control flow, or this new pattern of execution, is designed to handle errors, right? It's designed to handle errors by trying to find a part of the code that's prepared to handle an error that's caused by some other part of the code. Okay, cool. So I'll start getting into this. We'll finish up, come back to this and finish up on Friday, right? So in Java, the exceptions are actually broken into 3 different categories. And these have to do with whether or not, on some level, these have to do with whether or not the exception is a function of programmer error or a function of changes to the environment that are expected, okay? So the first type of exception is something called a checked exception. Why are they called checked? They're called checked because the compiler will check to make sure that you handle them. So in Java, if you call code that throws a checked exception, you are required to use a try-catch statement somewhere. You can put it in a variety of different places, but you are required to use a try-catch statement to catch that error. So essentially, these are exceptions that the compiler will check whether or not you are handling them properly. And these are, again, really great for cases where you know something could go wrong and you have to have a plan B. Whenever you use the internet on any device, you gotta have a plan B, because sometimes the internet goes up and sometimes it goes down, right? Same thing if you're trying to transfer a lot of data, it might take a long time. There's all these cases where you just gotta have a plan B, right? If you don't have a plan B and you're trying to access the internet or a file, for example, same thing, right? Maybe you're trying to load some data from a file, the user moved the file. Well, what are you gonna do now? I mean, crashing is one option, but there's usually better things to do, right? Unchecked exceptions, on the other hand, are usually caused by programmer error. These are usually caused by something dumb that you did. And so the part of the distinction here, right, you might think, well, why isn't Java trying to help me with these exceptions? Part of the problem is that Java can't help you with these exceptions because it can't determine every place that you might be doing something wrong, right? This gets into actually a really interesting discussion about different ways of doing program analysis. What can the compiler know about your code? But to make a long story short, there's no way for the compiler to ever prove that your code is correct. There's always different types of errors. I guess I shouldn't say that, but usually in most programming languages, maybe there are some languages where you can make that type of statement. But in most programming languages, the compiler can't prove that your code doesn't have a mistake. And so it can't find all the exceptions, and so it can't check all the exceptions. So some of the exceptions are unchecked, right? It might be better to call them uncheckable, right? The compiler can't necessarily guarantee that you don't use a bad array index, for example. And then finally, there's this third category that we're not going to talk about too much. These are called errors. These are serious problems with like the whole Java ecosystem that usually are not recoverable. That's not always true. Sometimes there are ways to recover from errors. You can catch them. But errors are things like you ran out of memory. Like your program used so much memory on the system, there's none left, or the program isn't able to obtain anymore, or something like that. At that point, it's not clear what to do. A lot of times errors end up just causing crashes because there's not necessarily a good way around them. Okay, so again, checked exceptions, these are times when an error is external to your program and it can cause a problem, right? Examples are like we just talked about. We're looking for a file and it didn't exist. Somebody gave you some input. So this happens a lot when you're processing input from a user. Like you said, enter a URL and the user entered food, right? And you need to be careful with that input because it might be incorrect. But you know it might be incorrect because you know that people don't follow instructions, right? So again, when you compile your code, Java will force you to handle all checked exceptions. If you don't do that, your code won't compile, okay? So let's see, I have an example here, right? So when I create, this is parsing a URI. So this is sort of like a URL, but in Java, there's an object class called URI. And if we look back over here at the URI, let's see here, let's go to the URI documentation. You'll see that the constructor, where is it? There's a lot of stuff here. The constructor, if I go here, you'll see that the constructor can throw an exception. So this is an example of a place where Java knows that a function can cause an exception. And so it's now my responsibility as a programmer to handle that exception properly. Okay, so let's go over here, let's look at this. If I try to compile this, the Java compiler won't even compile the code because it says, look, I know that when you call this constructor here on line 3 and try to create a new URI object, that process can fail. And so you've got to be ready for that. You got to have a plan B. And so if I want, and again, the plan B is very much up to me, right? So I can do this. I can basically say, try this. And if let's see here, URI syntax exception B, then I'll just return null. So this is one option. I can just, we'll just catch any exception here. Exception, right? So now this works fine, right? So now the compiler stopped complaining because it says, okay, well, you got a plan B. Your plan B is to return null. I don't know if that's a good plan B, but that's what you're going to do, right? It's always tough for me I always try to find something because strings are actually okay. What's not okay? Isn't that this? That's, I guess, is okay. There we go. So here's something that's bad, right? This is not a valid URI. It's something's wrong with the format, right? If I wanted to see what the error was, I could print this. It's probably not going to be very helpful. It's probably just going to say invalid URI. Yeah, expected scheme-specific part at line 3. Okay. I'm not sure I understand that error, but if I worked more with URIs, I probably would. All right. So, unchecked exceptions. Unchecked exceptions, again, are a result of programmer error. We've seen a few of these before. These are things that you can't anticipate. If you anticipated these, you would have fixed them in the first place, right? So on some level, unchecked exceptions have a relationship with bugs. Not every bug produces an unchecked exception. Some bugs just cause your program to behave incorrectly, right? Like if I ask you to write a function to compute factorial and you return 0, that's not going to ever cause an exception, but it's also incorrect. If I have you write a program to compute factorial and you try to be recursive and you forget a base case and you end up with a Stack Overflow error, now you're generating an error. That's an unchecked exception. Okay? And again, a lot of these are probably familiar to you because you've seen them either in the playground or on the program homework, right? So things like array index out of bounds exception, null pointer exceptions, class cast exceptions. Remember when we talked about downcasting? If I don't downcast safely, I can get this type of exception. Illegal argument exceptions. These are used by functions to indicate that you didn't pass the right arguments. These are all examples of unchecked exceptions. And here's the whole tree here. And I think there's a homework problem basically asks you to generate all of these different types of exceptions and give you some practice with just writing intentionally bad code, right? So again, I'm not going to go through this. Maybe we'll come back and play with this on Friday. So with unchecked exceptions, you can't, the compiler can't check that you have handled them properly, but you can handle them, right? That's not preventing you from using try-catch. It just means that the compiler won't force you to use try-catch. So for example, here, let's say that you and your partner are working on the final project and they wrote some code and you're like, man, a lot of times when I call this, it gives me a null pointer exception. And let's say you have a way of working around that. Sometimes you don't have a way of working around that. Sometimes you have to go to your partner and be like, dude, can you fix this code? But sometimes it's like, okay, well, if I catch a null pointer exception, I'll just do something to work around the problem, right? Errors, again, serious problems, not recoverable. Sometimes these are still your fault. They're a problem with your program. But part of the error handling mechanism in Java, the try-catch framework, is this idea of having a plan B. I can do something about an error. These errors, I can do something about an exception. These errors, on the other hand, are not necessarily things that you can really fix, right? Sometimes you can, but not always. All right, so I think this is pretty much where we'll pick up on Friday. Just one announcement for today. I hope everyone did well in the quiz this morning, or will do well this evening. The final project description is up. Our first assessment as part of that is going to be next week in lab. So next week in lab, we have a UI checkpoint. We're still working out the logistics of how this is going to happen, but you and your partner will need to present a bit of your progress to one of the core staff, which will kind of sign off. What we are expecting is listed in the project description, but you need to at least have a little bit of a UI skeleton set up so that we have some sense that you're making forward progress on the project. Other than that, I hope everybody's doing okay. It's, like I said, beautiful spring weather here today, so I hope you guys enjoy that a little bit. Get out, take a walk, be good to yourselves, be good to the people around you. I will see you again on